Because I'm the third speaker, I was able to see that I actually have to talk about Continental a little bit. I didn't have a slide before about 10 minutes ago. I have, let's see, so Continental Tires, we make tires. We make a whole bunch of different tires. My favorite are these because I am a mountain biker. We are a big company. There's like 250,000 employees. We are global. There's like 56 different locations. We were founded more than 150 years ago. Blah, blah, blah. Oh, and I packed in a hurry, forgot my fancy pants, so I went with corporate grunge. Okay? I hope you like it. And now I'm taking this off because I'm going to get hot very soon. And now we go into the part where I am in a corporate environment, and coming from academia, I am an R person, but the corporates are all Python people. And here I was actually going to show a video, but I was worried about, since I'm being recorded, worried about copyright infringement. So imagine we're watching that scene in Raiders of the Lost Ark. Indiana Jones is peering into the Well of Souls, and oh my God, all he can see is snakes, right? And why did it have to be snakes? Because, oh yeah, and I tried to do this with AI. Didn't quite capture it. And I did do a few more of my slides with AI. This is a warning. Those are the bad ones. The ones I did are the terrible ones. You'll be able to tell the difference for sure. So I had been working on a proof of concept for about 1.5 years. It had been approved for industrialization, so yay for that. But then the project lead and my peer programmer, buddy, friend, coworker had to go off and give birth to a human baby. So because she is based in Germany, she took 2 years of parental leave. And the team changed quite a bit. So we went from having 3 R programmers and 1 Python programmer in the development team to the inverse. So 3 Python programmers, 1 R programmer. This was also the first machine learning model that was going to be industrialized in Continental R&D. So a lot of people both wanted to be involved and had to be involved because we didn't know how to do a few of the things, right? First time, you have to get all of these people on board. So we have like R&D IT, we had the tire developers, which were our internal clients. We had R&D data science, which were the other, those are the 3 Python programmers. Okay. We had R&D tire testing, and then me from a more central data science team. And I sort of had to, defend myself against all the R&D people. But being from the central data science team, we sort of had part of the standards for the company, right? So I had to push a little bit on a few things. So in the beginning, we had a lot of, head-butting and stuff. And one of our first meetings together, the lead software engineer for R&D IT mentioned that we needed to rewrite all of the code in Python. There were more than 1,000 commits. There was more than 1.5 years of work. Most of the R pipeline was already containerized and deployed. So it was like, we really don't have to do this again. Eventually, we got past this sentiment, and we were able to focus on more important things like our actual goal. So deploying this machine learning predictive model to help the daily tire development process, right? And we needed to settle on the who, what, where, and why. Not the why, we know the why. make more money, right? Anyway, where essentially, deployment infrastructure, system integration, this is where we're like, with the R&D IT people, product specifications and requirements. Here we're talking to tire developers mostly. The monitoring and the maintenance, who is responsible for that going forward? That is data science team in R&D. And then how are we going to do this? Fortunately, at this point, all the higher ups said, oh, okay, so we know how to, we know the specifications at this point, now you guys go ahead and do it, right? So because it was left up to us, left up to the developers, then we had to internally come up with a way to make this work, right? So our daily development strategy started with just agreeing upon things. We needed to agree what kind of files are we going to output from our scripts. If we pre-process data, what am I going to output so that you can use it in the next step? So we agree on Parquet files for pipeline steps. Then our results end up going to a database where a Power BI can connect to and then grab those predictions and send those to the tire developers. Then we want to still be able to be productive, right? So we decided everybody gets to code in their preferred language, and just, nobody is forcing me to write in Python if I don't want to, and I'm not forcing anybody to write in R. So, yay. But here is where we do have to reach over out of our comfort zone, because we want to maintain or enforce the 4 eyes principle so that not just one person is looking at all the code and approving all their own pull requests. We do code review in whichever language is needed. So I will review Python code, they will review R code. Obviously, I am not a great Python code reviewer. I'm not going to make it, shine, but I can say, okay, I really don't understand what you're doing here. I think you need to document your code a little more. You talked about this object up here, but then you don't use it in the rest of the script, or things like that. So we can just make our code better, maybe at sort of a base level. And it seemed to work. For our deployment strategy, we also needed to do a few interesting things. So everybody, I bet, has gone through the "it works on my machine" shrug, right? Like somebody gives you some, if you're collaborating with somebody else, somebody gives you some code, and then you try to run it, and you happen to not have the exact same packages installed. Maybe you have a different R version, whatever. We need to make that not happen. We need to make sure that our code will run anywhere reliably. So at the bottom level, we need to manage our packages, right? Manage the environment in which our scripts are going to run. For R, we use Renv. And when I first submitted this talk, for Python, I used Poetry. Now we're using UV. And I want to make a little aside here to describe a few differences between those. Renv is very similar to Poetry, right? They both create lock files, which then with Docker will create a Docker image with. So it just takes that lock file, which has all of your dependencies, and then installs all of your packages into this nice little container with which we ship our scripts, right? And those eventually run wherever it is we ship them to. UV is not like Renv. When we're using UV, we use a base Docker image, which is a lot lighter than that Docker image that has the whole R environment installed into it. And UV at runtime installs all of the Python packages, but it installs it extremely fast. So it does not, it ends up being faster than downloading the Docker image that had the complete environment installed. So, and on top of that, it does one thing that makes me so happy, is that every time a developer uses a new package, I do not have to rebuild the Docker image. And that is huge. Huge. So, and I have recently heard that there is RV coming for R, or it's in the works, or there's something out there already. So if this will happen soon and it's usable for me, it would really, decrease my maintenance load. Anyway, back to what we had to do. So I already gave you a teaser about the fact that we have to containerize our environments, right? So that each language runs in its own environment. So as I mentioned before, when I was doing poetry or whatnot, I had that Python Docker image for the Python scripts and the R Docker image for the R scripts. Packaged into a container, all great. And then orchestration, we deploy this on a language agnostic platform. So the platform doesn't care what you're running, as long as you tell it, you configure how the different nodes will interact with each other. So essentially, imagine a node is one of your scripts. It does something. It can query the data. It can pre-process the data. It can run a machine learning model. It can run a SHAP analysis, whatever. All of these little building blocks for the whole pipeline are nodes. You tell the MLOps platform how these nodes interact with each other, how the inputs and outputs, where they come from, where they go to. And that's how we build a pipeline with mix and match language inside. So each node can have whatever language you want, as long as you have it containerized, and as long as you tell the platform what it is comes next. So you might imagine that it allows us to not only have these components that are in different languages, they coexist, but they also integrate, right? So it doesn't really matter if I did the query in Python. If I output a Parquet file, I can input it into an R pre-processing step and then run a model in R with a tidyverse, and I'll be totally happy. So the results of getting all of us to work together is that about a year after we started, no, a little less, like 7 months, we were able to deploy that multilingual machine learning model. Nowadays, it's used by more than 100 tire developers on a daily basis, and they are now getting overnight predictions for a process that used to last 4 months for them to get a decision on a tire. So they really love it. We are now working on another test. So this is for a high-speed test, and now we're working on an endurance test. But for me, how do you make R and Python play nice? Well, you got to get the developers to play nice, right? So we standardized data exchange formats. We took a very pragmatic approach to coding and code review, containerization for consistent environments, and language agnostic orchestration. That's pretty much the big takeaways here. And yes, R and Python can work together and make something productive. There's really no reason to rewrite everything. And one really nice thing that I like is that you can leverage the strengths of both. So there's some things that, despite what Python programmers say, there's still some things that R does better, and I would like them to do. Would like to do them in R, right? So I can still do that, but then I can also bring in the greatest and best from Python. So that's me. That's it. Thank you very much.